Today we're going to continue solving systems of linear equations, but we're going to use the substitution method. The substitution method is exactly what it says it is. It means we are going to be substituting something today. So let's go ahead and look at our first example. In this example, we're going to solve by using substitution. Now, when you use substitution, the best time to use it is anytime you have one or more of the equations that start off as y equals or x equals. So in these two equations, do you have one or more of them that start off as y equals or x equals? Well, if I look, I can see that this first one right here starts off as y equals 4x minus 1. The second one starts off as 2x plus 2y. That equals 3. So that's not going to work. So we're going to take the first one, and we're going to say y equals 4x minus 1. So this 4x minus 1 right here becomes what we're substituting in. So we're going to substitute 4x minus 1 in for y in the other equation. And we're going to solve it. So we're going to rewrite the equation 2x plus, instead of 2y, I'm going to write 2 times the quantity, and instead of y, I'm going to put 4x minus 1 in. And that equals 3. Now I want you to think about this as if I had an equation. Say I had x plus 4 equals 6, and somebody else said no, it's x plus 3 plus 1 equals 6. Well, 4 and 3 plus 1 are the exact same thing, so you're just substituting it. So that's exactly what we're doing in this problem. So now we're going to solve. We're going to distribute that 2. So we have 2x plus, and 2 times 4x is 8x, and then 2 times negative 1 is negative 2, and that equals 3. Now I'm going to combine like terms, so I have 2x and 8x. That gives me 10x. Then minus 2 equals 3. Now this is a two-step equation, so we're just going to add 2 to both sides. Drop down the 10x. My 2's cancel. That equals 5. Divide both sides by 10. Those cancel. And I get x equals 1/2. Now, to solve for y, I'm going to take that 1/2, and I'm going to plug it in for x in one of my equations. So I think I'll just do that to the first one. You can pick either one, it doesn't matter. So I'm going to take that and I'm going to plug it in for x. So now I have y equals, instead of 4 times x, it's going to be 4 times 1/2 minus 1. And I'm going to solve that. Y equals 4 times 1/2. 1/2 of 4 is 2 minus 1 equals 1. So x equals 1/2 and y equals 1. That's your answer. You must have both of them. Now let's look at this example. Same thing. Remember that you're looking for an equation that starts off with y equals something or x equals something. So which one of these says y equals or x equals? Well, that would again be the first one. It says y equals x plus 1. So let's go ahead and substitute in y equals x plus 1. So I'm going to plug that in for y. And I'm just going to rewrite my equation. So I have 2x plus, instead of y, I'm just going to put in x plus 1 equals negative 2. Now, the mistakes you don't want to make are, you want to make sure that whatever you're plugging in is in parentheses. Just in case you're multiplying it, it reminds you to distribute through everything. The other thing you want to be careful of, especially at the end where it says equals negative 2, you want to make sure that you're copying from the right problem and you don't end up doing like equals 1. So make sure your equation looks exactly the same and that you copied it correctly. That's the number one mistake, is just that you copied it incorrectly. All right, let's go ahead and solve this then. There's nothing to distribute here, so really I can just look at this as 2x plus x plus 1 equals negative 2. So I can combine my like terms, 2x and x, and I get 3x plus 1 equals negative 2. Two-step equation, so you're going to subtract 1 from both sides of your equation. If you want to draw the line, you still can. Those cancel, and you get 3x equals negative 3. Divide by 3, and you get x equals negative 1. Now that I've part of my answer, all I have to do is go ahead and plug that into another equation. So I'm going to pick the first one because it's already set up for y. And I'm going to plug it in. I'm going to solve for y. So I have y equals, instead of x, I'm going to plug in negative 1 plus 1, and that's super easy. Y equals 0. So those are my two answers. Okay, in this example, we want to solve by using substitution. So if we remember, we use substitution anytime we have an equation that says y equals or x equals. Now, if I look at these equations, is there one that says y equals or x equals? Well, as I look, neither one of them do. I have negative 9x plus 5y equals negative 1, and negative 3x plus y equals 4. So what I have to do is I have to force it. I have to make it work. So that means I need to solve one of these variables for either x or y. So I'm going to pick the easiest one. And the easiest one to do is the one that doesn't have a coefficient or doesn't have a number in front of it. So if I look, I have negative 9x. Well, if I solve for that, I have to divide by negative 9. I have 5y. If I solve for y, I'll have to divide by 5. I have negative 3x. If I solve for x, I have to divide by negative 3. And then I have y. If I solve for y, I don't have to divide by anything because there's nothing in front of it. So there's my answer. I'm going to solve this equation for y. So let's do that. All you're going to do is you're going to solve it just like you would any other equation. You're just going to move furniture around, as I say. So don't we want over here? We don't want this negative 3x, so we're going to move it by adding the opposite. Absolutely nothing new here today. Those cancel. My y drops down. That equals 4 plus 3x. There, now I have an equation that says y equals. And I am going to take that, y equals 4 plus 3x, and I'm going to now substitute that in for y in the equation that I didn't manipulate. So I didn't touch the first equation, so that's the one I'm going to plug it into. So be careful. Make sure you're plugging it into the opposite equation that you messed with, and make sure you're plugging it into the right variable. And make sure you're copying it correctly too. So there's a lot of thinking going on. So now I'm going to substitute it in. So I'm just rewriting that first equation, negative 9x plus 5. Instead of y, though, in parentheses, I'm going to put in 4 plus 3x, because that's what we figured out in the other one, equals negative 1. Now, you're going to go ahead and solve that by distributing. So I'm going to distribute that negative 5 to everything in the parentheses. So I have negative 9x. My x's don't want to work. Yuck. Plus 5 times 4 is 20. And 5 times 3x is 15x. Equals negative 1. Now I'm going to combine like terms, so I have negative 9x and 15x. That gives me 6x plus 20 equals negative 1. Subtract 20 from both sides of the equation. Those cancel, and I get 6x equals negative 21. Now you're probably starting to panic because, oh my gosh, it's not even, and that's okay. Divide both sides by 6, and you get x equals negative 21 over 6, which reduces to x equals, they're both divisible by 3, so negative 7 halves. And we're going to leave it like that, because once we divide it, we estimate it, and we don't want to estimate it. So now I have that answer. There's my answer for x. So I'm going to plug it in. It does not matter which equation you plug it into. I'm going to plug it into the second one because I don't have to worry about my y being multiplied by anything. So I'm going to have negative 3. Instead of x, I'm going to put negative 7 halves plus y equals 4. Multiply, remember you multiply the top numbers by the bottom. So I get 21, negative and negative give me positive, halves plus y equals 4. I'm going to subtract 21 halves from both sides of the equation, which if I look at this comes out as negative 10 halves. So I'm going to subtract 21 halves if you wanted to change it. This is really getting yucky here. Those cancel. I get y equals 4 minus 21 halves will give me negative 6.5. And if you want to make that a decimal, since it's terminating, you can. If it was non-terminating, I wouldn't.